Moving on to functions here. Functions don't work too strangely in Python, but the syntax is probably a little bit unfamiliar. So to define a function in Python, we use the def keyword here. So def squaret x colon. That means that we're declaring a function called squaret that will take in a parameter named x, and everything after that colon that's indented will be part of this function. Remember, white space matters in Python, so everything that's indented after this declaration of the function is going to be part of that function. In this simple example here, we only have a one-line function. It will return the value of x times x. So we're taking in a parameter x and returning the square of it by returning x times x. To actually call that function, it works exactly the way you think it would. You just use the function name and then the parameters within parentheses for that function. So we can print out squaret2, and that should print out the square of 2, which is indeed 4. So what happened here was we called the squaret function with the parameter 2. That value 2 got substituted into the x variable. We returned 2 times 2, which is 4, and that went back to the print statement, which printed out our final output. Now, one thing that's a little bit weird about Python is you can actually pass functions around just like their parameters, like their variables themselves. So I could create a more general function called doSomething here, for example, that takes in two parameters, f and x. And in this case, f is meant to be a function itself, and x is a parameter that gets passed into that function. So I can actually pass in any function I want into doSomething and any parameter I want, and it will return that function executed with that parameter. That's what's happening here. As an example, it's called doSomething with the squaret function that we just defined and the value 3. And what that should do is return the square of 3, which is 9. What happened here is that we passed in the squaret function into doSomething, so that function squaret becomes f, the value 3 becomes x, and f of x is what gets returned, so that just turns into squaret 3, which then goes back to the squaret function, which returns 3 times 3, which is 9. So squaret 3 comes back as 9. That comes back from doSomething and ultimately goes back to the print function here to print out our final result. We can also use something called lambda functions in Python, and that lets you inline functions without actually declaring them separately. So if you have a really simple function, you don't even have to write a function for it. Let's say we want to use our doSomething function that actually takes in a function that cubes things instead of squares it. Well, we don't actually have to write a cubit function. We can just write lambda x colon x times x times x. And this lambda function here is actually a function definition within itself. It has no name, but it's a function. So we have here a function that says lambda x. That just means that we're going to take a parameter called x and operate on that as part of this inline function. And the return value will be after the colon, which will be x times x times x. So this lambda expression here becomes the function that we pass in to doSomething. This is what's going to be f up here in doSomething. And the parameter that gets passed into that lambda function is 3. So doSomething lambda x, 3 is going to pass 3 into this lambda function, which will execute 3 times 3 times 3, which will be 27. And you can see that does indeed work. Moving on, let's talk about Boolean expressions. Seems like every language handles these a little bit differently syntactically. Equality is tested with the double equals operator, generally speaking. So 1 equals 3 will return false because 1 does not equal 3. You can also use words like and or is. So true or false will return true because true is one of the values. Either of those can be true to be true. You can also test for equality using 1 is 3. So the is operator can work as well. 1 is not 3, so that comes back as false. Now there is a subtle difference between double equals and is in Python that's worth talking about. With values they work the same way, but if these were actually objects of some sort of variables, is actually compares the actual objects themselves. So let's say we had, two different objects for, I don't know, cat and dog. If those both contain the same value, the equality operator would do what you want. That compares the values of the objects you're comparing. But is compares the objects themselves. So if I actually had two different objects that contain the same value, the is operator would return false every time because they're two different objects. But if they contain the same value, the double equals operator would actually return true because that's actually comparing the values within those objects. So very subtle difference there, but sometimes it can trip people up. There is a subtle difference between double equals and is when you're dealing with objects. Let's just do a really simple example here to show Boolean operations in action. So we'll say if 1 is 3, we'll print how did that happen. Obviously 1 will never be 3, so that should never happen. Else, if 1 is greater than 3, print yikes, that shouldn't happen either. But otherwise, we'll say all is well with the world. So we're also demonstrating the if, else structure here, which is very similar to other languages. But syntactically, again, a little bit different in Python because we have this significant white space here and colons that actually groups these blocks together. So if 1 is 3 colon, everything that's tabbed after that will be part of that if block. Else, if 1 is greater than 3 colon, everything indented will be part of that block. And finally, we fall through to else colon, and everything after that colon that's indented will be part of that block as well. Fortunately, all is well with the world. 1 is not 3 and 1 is not greater than 3. So we fell through to that final case.